Aspirants, welcome to AKP Study Circle. In this video, I am going to discuss practice sheet 2, 11th question onwards, and up to 10th question I have discussed in the previous video. I have given the link in the description, you can go to it. And these are the practice sheet 2 questions, and 10 questions I have discussed, and link I have given in the description. And 11th question onwards I am discussing. And if you are first time watching my channel, please subscribe to my channel and press the bell icon so that you will get the video notifications. If a wire of resistance R is melted and recasted into a half of its length, then the new resistance of the wire will be. And for better understanding of this question, I have created a diagram, just you can see this. A wire of resistance R is melted and recasted into half of its length. You see this, initially the conductor is like this, that means wire is like this, and after recast into half of its length, when the length reduces, what happens? Its thickness will increase. Its thickness will increase because volume remains constant here, because same material recasted into in this length, and in this case volume remains constant. So in case of volume remains constant, what is the formula you have to use? R equals to rho L by A, you know that, okay. For getting in terms of volume, because volume remains constant, so that you will get the relation between resistance and the length of the conductor. R equal to rho L by A, and in terms of volume, what you can say? Rho L square by V, okay. So how it came, I have explained in the previous video, means by multiplying with L on both sides, here and here. So L into L square it becomes, and area into length it becomes volume. So what you are getting the relation here, volume remains constant, so you are getting the relation between the resistance and length of a conductor. That means R is proportional to L square. So this one you can write it as R2 by R1 equals to L2 square by L1 square. So here what he has given, so length of conductor becomes getting off, then what happens? Here initially L1 length, it is become off, so L1 by 2 whole square by L1 square. What happens? So R2 by R1 equals to, so you will get 1 by 4 here. So L1 square will get cancelled. So R2 by R1 equal to 1 by 4 you are getting. So R2 equals to R1 by 4. So resistance becomes 1/4. So the correct answer will be R by 4. Next question. The resistance of a bulb filament is 100 ohms at a temperature of 100 degrees centigrade. If its temperature coefficient of resistance is 0.005 per degree centigrade, its resistance will becomes 200 ohms at temperature of. So in this question, 2 temperatures and 2 resistances given. So for this we know the formula R1 equals to R0 into 1 plus alpha T1. So in case of second resistance, R2 equals to R0 into 1 plus alpha T2. Okay. So 2 resistances, 2 temperatures given. So the formula is this one. And in the previous video also I have explained regarding this model. And for calculating this T2 value, just simplify this R1 by just equation. That is R1 by R2 is equals to 1 plus alpha T1 by 1 plus alpha T2 here. R0 get cancel. Okay, you are getting like this. And now do cross multiplication, this one. So R1 into 1 plus alpha T, what you will get? R1 plus this one. R1 into 1. R1 plus R1 into alpha T2. R1 alpha T2 equals to, do cross multiplication, what you will get? R2 plus R2 into alpha T1. So you need T2 here. So what you can write here? T2 equals to, that is, you can also write like this. In the previous step only you can leave it for better simplification. And what you will get? This goes to right side, that is R1 by this R1 into alpha you will get here. Substitute the values here. R2 how much given? The second resistance 200 ohms given. So the 200 into 1 plus alpha T1. 1 plus alpha how much given? That is 0.005. 0.005 into first temperature how much? 100 degrees centigrade. So that is 100 minus R1. First resistance how much given? 100 ohms given. So 100 right like this. by R1 into alpha. R1 how much? R1 100 ohms, that is 100 into alpha how much? 0.005. Just simplify this. And if you simplify further, what you will get? That is 200 into here 0.005 into 100. Just multiply this, what you will get? You will get 2 zeros here. So the point will move to like this. So 0.5 you will get 1 plus 0.5, 1.5 you will get. Okay. So directly I am writing this step here 1.5 minus 100 by in denominator 100 into 0.005 is there. When you multiply with 100, what you will get? This point will move to 2 zeros. So it moves to this one. So 0.5 you will get here. So 0.5. So 200 into 1.5, how much you will get? So this 0, this point will get cancelled. So 15 into 20, that is 300. 300 minus 100 by 0.5. Okay, 0.5 means 1 by 2. So 200 by 1 by 2, you are getting 400. And you are getting 400 as the answer. Diagrammatically also we can show this. You can see. So for better understanding, I have shown in the diagram. And for 100 degrees centigrade, you are getting 100 ohms. R1 you are getting 100 ohms. This is T1. And for this one 400 degrees centigrade, for T2 400 degrees centigrade, how much you are getting? 200 ohms resistance you are getting. Okay. For the temperature coefficient of 0.005 degrees centigrade. Next question. A rectangular block has a dimensions 5 centimeter into 5 centimeter into 10 centimeter. That means LBH you can say it is length, breadth and height. Okay. And calculate the resistance of measured between two square ends. Okay. Calculate the resistance between two square ends and the opposite rectangular ends. The specific resistance of material given is 3.5 into 10 power minus 5 ohm meters. So the rectangular block will appear like this. Two square ends has given. So two square ends here are for this rectangle block. These are the squares. And join this. And in this question he is asking the resistance between these two square ends. So this is one square and this is the another square, and between these two square ends is asking the resistance. So you know the formula, the resistance equal to rho L by A, the resistivity of the material into length by area of that conductor. Okay, R equal to rho L by A. So here how much given? Rho 3.5 given. So 3.5 into 10 power minus 5 into the length how much between these two square ends. What is the length has given? Length you can see. So which one is more? 10 centimeters. So this becomes the length we can say. So you need not consider this as LBH. So based on the length we can say it is a length. This one is a more length, no? We can take it as a length here. So based on the given question, whatever it is asking, based on that, between those two we have to take the length here. Okay. So what will be the length for this? Between these two square ends, this will be the length here. So it is given as 10 centimeter length it is. So which is more here? So these two are same and this one is different, which is more. So it becomes length here, that is 10 by. So area of this square end. What is the area of this square end? This one is 5 centimeter and this one is 5 centimeter. So what you can write it as? So 5 centimeters given, you need to convert into meters here. So 5 into 10 power minus 2 you can write. 5 into 10 power minus 2 into 5 into 10 power minus 2. Here the area of the square we are writing here. Okay, area of the square side into side, that is side square, and this length also given in centimeters. So just write this as 10 power minus 2, just converting into meters. So what you will get? 3.5 into 10 you will get 35. So 35 into 10 power minus 7 by this 5 into 5, that is 25. So 25 into, so 10 power minus 2, 10 power minus 2 you are getting 10 power minus 4. And if you further simplify, what you will get? 5 5 is a 25, 5 7 is a 35. So 5 1 is 5, there will be a 2 here, 5 4 is a 20. So 1.4 into here 10 power minus 7 here 10 power minus 4, it goes to numerator. So 10 power minus 7 plus 4, you will get 10 power minus 3. So 1.4 into 10 power minus 3 ohms you will get. Okay. And the correct answer will be 1.4 into 10 power minus 3 ohms. And remaining also we can calculate. And for second one also same model, that is R equals to rho L by A formula we have to use. And for this R equal to the resistivity of the material, that is rho into, so rectangle block just I have shown here. Okay, in this what he is asking, opposite rectangular ends, the resistance between opposite rectangular ends he is asking. That means these are the opposite rectangular ends and this is one side and this is the another side. Okay. So between these two ends we need to calculate the resistance. Okay. So R equals to rho L by A, you know that. And based on this given data, this one 5 centimeter given, this one 5, this one 10. So this one is more. So this is 10 centimeter between these two, and this becomes 5 and this becomes 5 here. And opposite rectangular ends resistance is asking. So between these two, so what you will get? Rho into length between these two. Length between these two is how much? That is 5 centimeters. You substitute the values directly. R equal to rho means how much given? 3.5 into 10 power minus 5. That is 3.5 into 10 power minus 5 into the length between these two ends. What is the length here? 5 centimeters. That is 5 into 10 power minus 2 by area of this rectangular end. Area of this rectangular end how much? That is this one multiplication with this one, that is 5 into 10 power minus 2 into this 10 into 10 power minus 2. Just simplify this. So here 5 into 10 power minus 2 and 5 into 10 power minus 2 will get cancelled. And here, so 3.5 you are getting here. 3.5 into 10 power minus 5 into, and if it goes to numerator, what happens? This becomes 10 power minus 1. So if it goes to numerator, you will get 10 here. So 10 power 1 you are getting, that is 3.5 into 10 power, so minus 5 plus 1, that is minus 4 you will get. Okay. So 3.5 into 10 power minus 4 ohms you are getting. So the second one answer will be 3.5 into 10 power minus 4. And in this way we can solve this problem. And if you want to write a formula for each case clearly for descriptive, and you can see for in the first case for these two square ends, what you can write, this is the more length, so we can take it as L here, and this is height, take it as height H, and this one you take it as breadth here. Okay. So then what happens in case of first one, what you can write the formula? R equals to rho into, so between these two square ends he is asking. Okay. In the first case, between these two square ends he is asking. Okay. What you can write? Rho into length. Okay. What is the length between these two square ends? That is L by A. A means area. A means area of this one. Okay. That is breadth into height you can write. Okay. Breadth into height. Okay. You can simply directly solve this, but if you want to write a formula and want to substitute the values, you can use this. Okay. In the first case you can use this formula, and in the second case R equals to rho into, and opposite rectangle ends is asking the resistance between opposite rectangle ends. So this is the opposite sides of this rectangular. So what is the length between these two? That is breadth here. So the distance between these rectangular opposite ends is B, that is breadth. So rho into B by, and the area of this rectangle, what you can say? Length into height. So L into H you can write. Okay. You can use these formulas for solving this question, or you can directly and solve the question by substituting the values. So based on the concept. And if you have any further doubts, you can ask in comment section. I will reply to each and every comment. Okay. And thanks for watching this video. Please like this video and share this video with your friends. And don't forget to subscribe this channel for more videos. Thank you.